Hello, this is Mrs. Grosch, and the topic for today's lecture is mass, volume, and density. You've probably heard of mass and volume from previous year's science classes. Density might be a new idea, but I'm hoping you'll understand it after you listen to today's lecture video. Mass is the amount of matter in an object. It's similar to weight, and on Earth you can think of it as very similar to weight, but weight depends on gravity and mass does not. So in the science lab, we usually measure the mass of a substance. We measure mass with a tool called a triple beam balance. It looks like the picture you see in front of you. When you measure with this object, the unit that you use for your measurement is the gram. You should be familiar with the different parts of the triple beam balance. In this picture, I've identified the names of the different parts. The part that you put the object you want to weigh on is called the pan. And on the opposite side of the balance, you have the pointer. When you measure with the balance, what you're trying to do is to get that pointer so that the mark on it is lined up with the 0 mark on the very edge of the balance. You can see that that's not true in this picture, but I'll show you how to fix that in a few minutes. Two other parts that are very important are the beams. There are 3 beams, which is why it's called a triple beam balance, and the little weights that move around on the beams. Those are called riders. Before you begin to measure anything with the balance, you need to make sure that all the pointers are at 0, the way they are in this picture. Before you put your object on the pan, double check the pointer. Make sure it's pointing at 0. You can see in this picture, it's not pointing at 0. But if I look at the pan, it's empty. So that doesn't make sense. There's something wrong. This is a very common problem and it's easy to fix. If you look closely at the riders, they look like they're at 0, but actually they're not quite. They're a little bit too far to the left. And that's why that pointer was not at the correct spot. This is something you can correct pretty easily. All you have to do is make sure that the riders are actually in the notches. Maybe you heard a click. That click is the riders falling into place. And you can see how it's corrected where the pointer is. It's much closer to the 0 mark than it was before. That's what you need to do before you begin to measure your object. Once you've got the pointer where you want it, put the object that you'd like to measure on the pan. Once you do that, you're going to start moving the riders. Now you start with the biggest one, and that one measures 100 grams at a time. So you move it from the 0 mark to the 100 mark. If that's too far, put it back to 0, but remember, don't go too far back. It should fall into the notch. Once you've done the 100 gram weight, then move to the 10 gram. Again, you'll move it over one notch at a time. If it goes too far, you have to move it all the way back to the previous notch, even if that doesn't look like enough. You never stop it in between 2 of the spaces. Now the last one, which is the smallest rider, that one doesn't have notches, so it can move freely anywhere you want it on the beam. You'll keep moving it and adjusting it until the pointer really is as close to the 0 mark as you can get it. Do the best you can, be patient with yourself, and try to get it as close to 0 as possible. Once you've got it as balanced as it's going to be, you need to know how to write down the measurement of mass that you have. Looking closely at the riders and the numbers they're pointing to, I can see that the one that's largest is pointing at 0 grams. The one that's medium-sized is pointing at 50 grams. And the smallest one, well, it's between the 4 and the 5. Each one of those small lines between the 4 and the 5 is 1/10 of a gram. So if I count over, I'll discover that it's 6 little lines past the 4. That makes it 4.6 grams. Adding those together, I get a total of 54.6 grams, which I can abbreviate with just a lowercase g. Something else that you can measure is called volume, and volume is the amount of space something takes up. You can think of it as how big something is. Gases have volume, as you can see in that picture, but we are going to mostly work on measuring the volume of solids and liquids. In our class, we mostly use graduated cylinders as the tool to measure volume. And when you use a graduated cylinder, you'll use the unit milliliter for your volume measurement. A cubic centimeter can also be used to measure volume, and a cubic centimeter is the same amount of space as a milliliter. So in many ways, they're equivalent. To measure the volume of a liquid, what you'll need to do is pour it into a graduated cylinder that's big enough to hold all of the liquid you have. And then notice the number scale on the graduated cylinder. This graduated cylinder is measuring in milliliters, and the water level is between the 50 mark and the 60 mark. You can count up the little lines, and you'll discover that it's at about 56, 6 lines higher than the 50 mark. So the volume of water in that graduated cylinder is 56 milliliters, which you can see I've abbreviated 56 ml with lowercase letters. It's a little trickier to find the volume of a solid. Now, some solids have a perfect regular shape, so you could use a math formula like length times width times height, but that only works part of the time. So often what you have to do is use a method we call the displacement method. I'll show it to you now. You start by putting some water into a graduated cylinder and make sure you measure the amount of water you have. Then you take your solid object and, trying to be careful so that you don't slosh the water around, you add it to the graduated cylinder. What you may or may not have noticed is that the water level went up. If you compare the before and after pictures, here I'll make them a bit bigger for you, you can see that the water started out at about 56, because it's the same graduated cylinder I used before, and it went up to around 60. Now, we didn't add any more water to the graduated cylinder, but we did add this solid object. So I know that its volume is the difference between 60 and 56, so if I subtract those, it's pretty easy, and I get 4 milliliters. That's the volume of the object that I added. One of the reasons for measuring the mass and volume of a substance is to help you figure out its density. Density is how heavy something is compared to its size. In other words, it's the mass something has compared to its volume. And this is an important way you can help to understand what kind of object or what kind of material it's made out of. There's an old riddle that goes like this. What weighs more, a pound of feathers or a pound of lead? Then actually they would weigh the same. They would each weigh 1 pound. The difference is that a pound of lead wouldn't take up very much space, but to get a pound of feathers you'd need a lot of them. And that's because there's a big difference in the density of lead compared to feathers. Lead is heavier for its size, and feathers are very fluffy and lightweight for their size. Knowing about the density of an object is very helpful, but you have to know how to calculate it. Density is calculated with a formula. You start by measuring mass and measuring volume, and then you divide them out. The density is the mass divided by volume. Because mass and volume have different units, the density has a unit that is the mass unit over the volume unit, for example, grams per milliliter or grams per cubic centimeter. I've got those written out for you, and now I've added the abbreviations. The reason that calculating density is important and helpful is because different pure substances have different density numbers. And if you can calculate the density of something and you don't know what it is, you can look in a chart and it'll give you a much better idea of the identity of that substance. So density is a very useful property. And it's a property that we'll use when we start to study rocks and minerals. Well, this concludes the lecture on mass, volume, and density. Thank you for listening. I'll see you in class tomorrow.